Okay, so here is the objectives for today's training section. It's about 3D rendering and the visualization in Imaris. So we will cover today about 2, 3, 4 topics. First, I would like to start introducing some useful functions in edit menu, including how to crop your image and how to add or delete the Z slice and the channels. Then we will go through the 3D volume rendering in different display mode, maximum intensity projection, blend mode, normal shading, how you can use them to display your or to view your data better. And we will go through the 3D sectioning tools in a different slicer. And the last one is how to add multiple images to the scene. So you can either overlap them or combine them or compare them, multiple images. Okay, so we will start from the functions in the edit menu. I will just use these demo images in Imaris. So in last session, we have introduced this arena view. So if you still not very familiar or not sure how to use arena view, you can go to the YouTube channel or download the videos from the link which Deborah provided about the training in the last session. Okay, so here, this image is a planned images, and if you go to the edit menu, you will notice there are some add and delete functions. So first, I will show you these add or delete slices, which you can add or remove the Z slice from your or into your images. So here, if you have some empty Z which you want to remove from your data images, you can use these delete slices and enter the numbers of the layers. You can enter either a single number or a range of numbers. For the number of slices, you can check the numbers on the bottom left. This is the layer numbers for the current Z slice you are viewing. Okay, so here you can add or delete slices. To add slices, you have to point to the other Z images in your folders. So you can have a multiple selection, but to add the Z slice, it must be the same size. Otherwise, it cannot be added to the same file. Okay, so you can use these functions here. Let me just restart it. Okay, that is the slices, and the channels is the same. So you can add channels, and you can delete channels, unnecessary, unwanted channels. So during the processing, sometimes you will create multiple channels, and in the end, if you want to delete it, you can delete the channels from here. Delete and add channels. Another one is the crop 3D. So for this data set, if there are a lot of empty space and you want to crop it to reduce the size, you can use this crop 3D. So once I click the menu, you will see this window, and you can choose the area you want to crop using this yellow rectangle. in XY, XZ, and YZ, so you can freely adjust the area using these functions. But in here is only a rectangular, not the freehand size. If you want to do the freehand size, there is currently no freehand crop in Imaris, but if you want to use that for analyzing a specific region, we have another way of doing it by using the surface mask. So in the later session, we will talk about that. This is how to crop your images. So once you decide the range, you click OK. Then Imaris will crop this image for you. Then it's better to use the save as to save as another individual data set. So that is some useful functions in the edit. It might be useful for you when you processing the images. All right. So next we will talk about the different rendering mode. By default, when you open the image in Imaris, it is always under the maximum intensity projection mode, as you can see from the volume object properties here, MIP mode. So for fluorescence images, MIP mode give you the maximum intensity pixels along the viewing axis, so you can see the details of your images like this. Whenever it's on the back or on the front or in the middle, as long as the pixel is the brightest pixel, then you will be able to see it. So it looks like a transparent and looks like a little bit flat. The flat, I mean, there is no like 3D feeling, like orientation in object orientation in the 3D space. So sometimes, in order to display images better, we can change the display mode, the rendering mode, to either the blend mode or normal shading mode. So let me show you about the blend mode first. So in MIP mode, as you can see, for example, for these cells, these two cells, actually it is a bit unclear how their position, what's their position in 3D space, like which one is more close to your eye view or which one is at the back. Okay, so as you can see, actually this one, small one, the bright one, is actually at the back, side. But due to this display mode, it is still, they are overlapped, and you cannot see clearly from a single view which object is on the front, which object is on the back. So once you switch to the blend mode, you will see immediately there is some difference. There are some difference. So first difference is this blend mode take into consideration of the opacity of the object. So the object which is close to your eye view will be displayed. On the other hand, the object which is at the back will be like blocked by the object on the front. So by adjusting this opacity, you can have a different effect. Okay, so let me introduce this transfer functions here. So once you switch to blend mode, you can see two channels, all the channels here. So you can adjust this transfer function for each channels. So let me focus on the green channel first. So I want to turn off this red channel. So here you can see this vertical axis is the opacity. So when I hold the left click and adjust this line, you can see the opacity change. And if opacity goes lower, you will see more like transparent effect. If higher, then you can see this opacity object, opaque object. And the left horizontal axis for this transfer function is the maximum and the minimum intensity of the pixels, voxels. So by adjusting this vertical and the horizontal axis, you can adjust the display of the blend mode to match the result you want to show. For example, like this green one, you can see it is now be more 3D-like display. And also, you can adjust the minimum and the maximum in the display adjustment window to have a brighter display on your voxels. So by adjusting these transfer functions here and the display adjustment minimum and the maximum intensity, you will be able to have a better display of your images like this. One of the useful sample for this render mode is usually like this neuron sample. There are a lot of crossing and overlap, so you cannot see clearly about its 3D orientation of the dendrites. So sometimes you can just change to a blend mode. So immediately you will have this 3D-like display. And by adjusting these transfer functions in the blend mode and the display adjustment, you will have this effect without doing any segmentation, okay, like this. So this is a blend mode in the graph shape is step. There is another graph shape is a peak mode. So as you can see, when I change from the step mode to peak mode, this transfer function shape changes. So here we can adjust in the peak mode, we can adjust this minimum and the maximum intensity. So it only displays voxels with the intensity in the middle here, under this or within this triangle area. So what does it mean? It excludes the dark pixel and the bright pixel, only display the pixel with the middle intensity, which usually for the fluorescence data is the shell, like the edge of the object. So if you want to display effect like this shell of the fluorescence staining object, sometimes you can use this peak mode to display the edge of the object. For example, this neuron sample, or for the one I just showed, for example, like this, for this red color channel, if you go to blend mode and use the peak, and try to adjust. So you can see in the middle, there is a object, and if you turn on the green signal, you can actually try to display. There is a green object inside. Actually, there is a green object inside the red channel. Okay, so you can use it for a different purpose. So we provide these two transfer functions for the blend rendering mode. Okay. So next one is the normal shading. Normal shading is similar as the blend mode. It also takes into consideration of the opacity, minimum and the maximum. Then it introduced pseudo-lysos, so you will be able to see the surface details because of the pseudo-lysos introduce the shading. So if you have an object which you want to display the surface up and downs or some details, then we can try to use the normal shading mode. So for example, for this data, I have some big surface blood vessels here, which there might be some details on the surface, but from the MIP mode or blend mode maybe I can see a little bit, but not so clear. You can see there are some up and downs. So if I want to display or show these surface details, we can try to use the normal shading mode. So once I change to normal shading, you can see similar transfer functions here. And by adjusting these transfer functions is also the opacity and the minimum and the maximum. So by adjusting these transfer functions, you can see the difference. And there are some shadings. The light source direction is from the here, upper left. From the upper is at the upper left. So here you can see the shadings on the back side. So by introducing this light source, pseudo light source, you can see this shading at the surface like this. This result is similar, very similar with the surface creation, but you don't need to do actually the surface rendering using the surface modules here. So sometimes if the data set is very big and you want to show this kind of effect in the surface details, you can do it by using the normal shading mode without really going to the surface and run all the process and do the surface rendering. So this is a quicker way to do it. But of course, if you need the analysis, then you still have to go to the surface and run the surface module. So here is the normal shading mode. And normal shading mode is only one graph shape, no peak shape. Keep peak shape as in the blend mode. Okay, so you can see the difference. There are slight difference between blend mode and normal shading mode. The last one is the shadow projection, but we don't usually use these functions because this is not optimized for the big data set. The result looks similar as the normal shading mode, and we usually or never actually, in my experience, we never use these options. So I can show you shadow projection. There is not much we can change, and the display is not as good as the shadow normal shading or blend mode. So usually we don't use these functions at all. So I won't go into details about this shadow projection. So usually we use MIP mode for analysis, and sometimes for display we use blend mode or normal shading mode. Okay, and you can notice there is a rendering quality here. So this actually does change the render quality on the display window, in the display window. So if you change this render quality to the maximum, it will display the full details of based on the current zoom range. But sometimes if your data is big and the system performance is not super good, we can try to reduce this rendering quality when doing this analysis. But when you want to do the snapshot or animation with the maximum quality, you have to change this. You can try to change this to the maximum position here. Okay, so by default, it is about 90% or 85% of this. So we can try to change this option as well for the best display in the snapshot or animation.